write the balanced equation for the reaction of sodium chloride and sulfuric acid, making sodium hydrogen sulfate, which is NaHSO4, you were given that formula, and hydrochloric acid. We know that sodium chloride is NaCl, and we know that sulfuric acid is H2SO4, and it yields sodium hydrogen sulfate. And again, you were given this formula along with hydrochloric acid, which is HCl. We got to check and see if this is balanced. I see that I have one sodium on the left and one on the right. I see that I have one chlorine on the left, one on the right. And I see that I have one sulfate on the left, one sulfate on the right. And I have two hydrogens on the left, and I still have two hydrogens on the right. They're just split apart into different compounds. Here's a hydrogen, and here's a hydrogen. I have a balanced equation. So lucky for us, this is a 1-to-1-to-1-to-1 ratio, which is going to make our math incredibly simple. Okay, number 6 says, how many moles of hydrochloric acid can be produced if I mix 7.3 moles of sulfuric acid with 6.5 moles of sodium chloride? So again, we're going to have to determine limiting and excess reactant to determine how much hydrochloric acid will actually be produced. And the limiting reactant will be the one that produces the right amount of hydrochloric acid. So if I have 7.3 moles of sulfuric acid, I know that if I have moles of sulfuric acid here, I have to have moles of sulfuric acid here. Overall, I am looking for moles of hydrochloric acid, which means that my answer will be in moles of hydrochloric acid. Again, I told you, since we have a 1-to-1-to-1-to-1 ratio, the math in this is very, very easy. Because I have an understood coefficient of 1 here, I know that I have 1 mole of hydrochloric acid in my balanced equation. Same thing goes for sulfuric acid. I have an understood 1 here, meaning I have 1 mole. Anytime you have 1 over 1 or any number over itself, the answer equals 1. So 7.3 times 1 is simply 7.3. So I know that 7.3 moles of sulfuric acid will produce 7.3 moles of hydrochloric acid. So now I need to know how many moles of hydrochloric acid 6.5 moles of sodium chloride would produce. And you can already see that because I have a 1-to-1-to-1-to-1 ratio, you could probably figure out the answer without even writing the equation out. But let's go on ahead and write it out to make sure we're on the same page. If I have moles of sodium chloride here, I know that it'll go down here on the bottom of the equation. Again, I'm looking for moles of hydrochloric acid. Therefore, I will get moles of hydrochloric acid. In my balanced equation, I have 1 mole of hydrochloric acid, and I have 1 mole of sodium chloride. 6.5 times 1, or 1 over 1, is going to be 6.5 moles of hydrochloric acid. So again, the question is asking how many moles of hydrochloric acid would be produced from these two reactants. I know that I have to figure out the limiting reactant, which is this one right here, because it produces the least amount of product. I see that 6.5 is less than 7.3, so this right here would be the correct answer for that question. Which takes us into number 7. What is the limiting reactant in this problem? The limiting reactant is sodium chloride, and it's limiting because it produces the least amount of product. And we know if this is limiting, this has to be excess, meaning I will not use all 7.3 moles of sulfuric acid that I have initially in the problem. Which takes us to number 8. How much of the excess reactant from this problem is left over? So how much of this 7.3 moles am I going to have left over? So how we figure this out, I'll go ahead and erase this. I determined that the 6.5 moles of sodium chloride was my limiting, and I know that some amount of that sulfuric acid is going to be left over. And if I have moles of sodium chloride here, I have moles of sodium chloride here, which is going to give me, again, moles of sulfuric acid. Again, easy problem. You've got a 1-to-1 ratio in that problem, meaning if I have 6.5 moles of sodium chloride, I'm going to use 6.5 moles of sulfuric acid. If I initially had 7.3 moles of sulfuric acid and I only used 6.5 of them, how many would I have left over? You take 7.3 minus 6.5, and you are going to get 0.8 moles of sulfuric acid left over, meaning you have an excess of 0.8 moles of sulfuric acid left over. And then the last question, number 9, says, write a short essay explaining the difference between expected or theoretical yield versus actual or experimental yield. And I gave you a hint. I said to use the last section of chapter 9 in your book. Basically, your expected or theoretical yield is what you mathematically calculate. So we mathematically calculated that I should get a certain amount, or 6.5 moles of the hydrochloric acid. That would be my theoretical yield. But assume we were in a lab. My actual yield, or my experimental yield, could have been 4.5 moles. For whatever reason, I didn't get that calculated value of 6.5. So that's the difference between experimental versus the actual yield. And you can actually take actual yield divided by the projected or expected yield, multiply that by 100, and that will be your percentage yield, how much you actually got out of what you expected.